Okay, let's pick up where we left off yesterday. So we've just broke this code, and today I want to focus on actually encoding our own messages. So first thing we're going to do is I want to write an encode function, def encode, which is going to take in some plain text, and it's also going to take in the alphabet that we're going to use to encode our message. So remember, we've been starting off with an alphabet, A, B, C, D, E, F, G, and so on, and then we've been figuring out that we want to replace A's with G's and B's with H's and C's with A's and so on and so forth. So this alphabet here is the one we're going to substitute into our encode function to tell it how to encode our message. So let's just call that something like the Cipher alphabet. Cipher alphabet. And remember, we used that really handy function called makeTrans a few days ago. We're going to create a translating table. I'm going to call it our code wheel, and I'm going to say to string dot make trans, and remember we have to feed in two strings. We feed in our alphabet along with our cipher alphabet. And that's all we need. That's all we need to do our encoding. And then I'm just going to take my plain text and I'm going to translate it using our code wheel. And that's what gets returned. So let's give that a quick go, make sure that's okay. I'm going to call my encode function. What am I going to call it with? What am I going to call it on? Let's just use our sample text from up here. I'm just going to come down here and call it plain text. And I'm just going to say plain text equals sample text. I can change that later, but right now I just need anything that's written in a way that I can read. Plain text. And I'm going to print out that. Let's see what that looks like. Ooh. Oh yes, I just left a load of gibberish there. Let's get rid of that. Encode missing one. One required positional argument, cipher alphabet. Oh yeah, sorry about that. What's my cipher alphabet going to be? I need an alphabet that's kind of shuffled about a bit. So I need to think about that just a moment before I can encode anything. I think what I'll do is I will create a shuffled version of my alphabet. So I'm going to store this in a variable called key, and it's just going to equal, I'm going to go to my random module again. Remember the random module? Included up here. And when we include a new module, we have to click and run that just to make sure that has been imported. I'm going to use random. I'm going to do random sample alphabet, and I'm going to choose, obviously I have to tell it how many letters from the alphabet I want. I want all of them, so I'm going to say len alphabet, and that's my key. And just to make it clear what that key is, I'm going to print it out for you as well so you can see. If I run this, my key, something's not working, but we'll save that for a moment. The key is just this thing here. It's our cipher alphabet that's going to shuffle all of our things. And of course, what I've forgotten to do is turn it back into a string. Remember, we have to do that. And the way we turned a list, this is a list, into a string is we use this join function. So I take an empty string and I use that to join all of the things in my list together. So if I do that, everything should be happy. And it isn't. String has no attributes make trans. Oh no, it doesn't. Sorry, I've used the wrong thing. It should be str. There we go. Slowly waking up, and there we go. We've used this alphabet to encode our message, and it's given us this whole load of gibberish. Now, I should say that there is a little disadvantage to using a completely randomly selected alphabet, and that is that it's really hard to remember. You and your friend both have to exchange a copy of this, which is not easy because you're trying to communicate securely. So how do you communicate this message to each other so that you know how to decode one another's messages. So a good plan is to find simpler ways of building a scrambled version of the alphabet. And I'm going to show you one of those ways right now. It's kind of cute. The idea is you take the alphabet and so on, and you take a word. Maybe the word is cat. And you remove all of those letters from the alphabet, C and A and T somewhere off there, and then you put the rest of the alphabet there. And so that gives you a slightly shifted and shuffled version of the alphabet to use. It's not the best, most random way of doing it, but it's not bad. Obviously, you can't use a keyword that has a repeated letter. That's the only restriction on this. So let's write some Python code that does that. I'm going to have a variable for keyword equals cat. And what am I going to do here? I need to take my key alphabet. I'm going to have a variable to store my alphabet. Key alphabet equals. We're going to take the string alphabet and just remove all of these characters from it. So let me think. Maybe the best thing for us to do is to say key alphabet equals. Let's start off by just making it. Remember that our alphabet is literally a string with all the alphabet letters in, and we don't want a string because strings can't be edited. We can't remove anything from them, and we need to be able to remove these letters. So I'm going to take my alphabet and I'm going to turn it into a list. Remember, the lists are the ones that have square brackets with things inside them. And the way to do that is you just use the word list, and we call list on alphabet, and we'll now have an alphabet that is an actual list. Let me just print off what all of that means so you can see what I'm doing. Key alphabet. If we print that out, you see it's just the alphabet but in one long list. And now what I'm going to do is I'm going to go through my key alphabet for actually, I'm not going to go through the key alphabet. I'm going to go through the for letter in my keyword. In keyword, I'm going to go to my key alphabet and remove that letter. And let's print that off. Let's print off what is left of key alphabet after that. And you see now C and A and T are missing. So we've trimmed them off, and we now just need to tack them onto the front. So I'm going to do that right now. I'm going to say my key alphabet equals my keyword plus the original key alphabet after it's had those letters removed. And so now if we print that, oh, must be string not list. Yes, I don't think we can just add. We can't just add things together like that if they are lists. Because that's a string and that's a list, so they don't like that. So we have to join them all together again. We're going to do this by doing keyword plus, and we're going to use the join trick again, just to turn that key alphabet into a string, and then we can add them together. There we go, and now you see I have my keyword alphabet with the word cat in front, and I can just create a new alphabet anytime I want by just changing that word. There we go, and we've removed those letters from there. Cool. Okay, so let's have a go at using this keyword technique to encode things. So I can come down here. I'm not going to use this random code anymore. I don't want to use that. I'm going to encode using my key alphabet. There we go. I should really print that off though. Print off my key alphabet just so I'm sure that I know exactly what I'm using to actually encode things. Yeah, looks good. If you want to use a longer word, you can, but just be on the lookout for repeated letters. It'll get upset. In fact, if you have a repeated letter, you'll probably get an error at some point. List remove X, X not in list. Yeah, it's because it removes the E the first time, and then it comes to this one and tries to remove it again and finds that it isn't there and doesn't know what to do. So, don't have repeated letters. It all works fine. And so now this is a much easier way to remember the key alphabet that we're using. Now what I want to do next is we have an encode function. Yesterday we worked on a decode bit of code, but we didn't actually wrap it up in a function. So I think we should do that. And it's really similar to our encode function anyway. We're just using a code wheel. Remember this make trans thing? So let's go ahead and define ourselves a decode function. And decode is going to take in a Cipher text string, and it's going to take in a guess key. Let's call it a guess key. And now we can just go ahead and indent all of these into the function. And I just need to carefully rename anything. So decoder wheel is make trans alphabet, and this is now called a guess. I'm calling it a guess key. Full line in Cipher text, yeah, that's the same name. Split, print the line, and translate according to the decoder wheel. Cool. So now I should be able to use this function just by calling it the decode. And I was using the Cipher text and the guess alphabet. Let's run that, and it shouldn't change. It does change. Ah, and I just forgot the colon at the end of a line. Never forget those. And away we go, and it decodes perfectly. So now we have that nicely wrapped up in a function. So now we have a decode function and an encode function. I think we can do a little better with this encode function. I want this to look really intimidating and horrible. And at the moment, it's making life a little too easy. For one thing, it's leaving punctuation in. Punctuation gives an attacker way too much information. So I think we need to remove the punctuation, and we need to remove really the spaces between the words. We can easily, if you can decode a code, you can easily figure out where the spaces go. So we should take out spaces and punctuation. And in fact, there's a really nice way of doing that make trans makes possible. If you Google Python make trans, it'll take you right away to the documentation. In fact, if you leave your cursor over this, it actually pops up. Google Colab will pop up some documentation, and yeah, if it receives a third thing, a Z, a third list, it treats that list as all the characters you want to just remove, which is really handy. So I'm just going to go up here and put an option, remove characters. And by default, I'm just going to set that equal to an empty string. So by default, I don't want to remove anything at all. But if we want, we can ask it to remove a few things. So let's do that. We've already got our key alphabet up here, but why don't we think up what characters we want to remove? So I'm going to create a new variable, cars to remove. What could it, well, punctuation first of all, and this is where string comes in handy. You'll find that the Python string class has a load of punctuation just stored in this handy variable for you, so you don't have to go through your keyboard tapping every single key you can think of. This gives you practically every item of punctuation you can think of. So let's say cars to remove equals string punctuation, and let's see what that does. I just need to include this in my file up here, in my function up here. Remove characters, it'll be those, and away we go. Let's run that. And you see here, doesn't actually seem to have removed anything. Did that do anything? Ah, it's because I didn't do it I didn't actually call it. So I need to include that there. There we go, cast to remove. And let's run that. Yes, it's removed some of them. It's also left behind a few. For some reason, these symbols are not included down there, although they look very similar, but they're not in there. Okay, so I'm just going to copy and paste those and put those in. Custom. I'm just going to do it like this, plus some custom strings that we might have to add that one, and then I think there's a different one as well. The one on the... Let me see. Let's run that again. Anything else get left? Yep, so there's a slightly different one as well. How strange. Put that in there. That one as well. Oh yeah, you can see those are different, yeah. And there we go. And finally, let's remove spaces. That's really easy. We just have to also... I'm going to do it as a separate thing just so it looks clear. But yeah, just add in a space. And away we go. Yeah, that looks far more horrible. Which makes me happy.